हेलो बच्चों, this is the lecture number 15 of the unit Electrostatics, and in today's lecture we will study about dielectrics and electric polarization. First topic is dielectrics. Dielectrics are those materials which don't allow current to flow. In dielectrics, the charges are attached to specific atoms or molecules, unlike conductors. These charges can move a little bit within the atom or molecule. Dielectrics can be polarized by an applied electric field and is an efficient supporter of electrostatic fields. Therefore, we can say dielectrics are an insulating material which transmit electric effects without actually conducting electricity. So we can say dielectrics don't conduct electricity actually, but they transmit the electric effect of the external electric field. There are certain examples of dielectrics. Gaseous dielectrics are dry air, carbon dioxide, nitrogen, hydrogen, etc. Solid dielectrics are ceramic and glass, etc. Dielectric liquids are distilled water, transformer oil, etc. Vegetable oil is also a liquid dielectric. Dielectrics has two types. First is non-polar dielectrics and second is polar dielectrics. First, non-polar dielectrics. In non-polar dielectrics, the center of mass of positive charges coincides with the center of mass of the negative charges within the molecule. The term center of mass you have studied in class 11, and the center of mass of the body or a system of bodies is the point at which the entire mass of the body or system of bodies is supposed to be concentrated. Or in other words, we can say it is the point about which the entire mass of the system is equally distributed. Moving to our next point in non-polar dielectrics. Non-polar dielectrics are symmetric in geometry, hence they are non-polar. In the absence of electric field, each molecule has zero dipole moment due to its symmetrical shape. But when electric field is applied, molecules get polarized. Some examples of non-polar dielectrics are carbon dioxide, methane, benzene, etc. As we can explain this, carbon dioxide is a linear molecule having two CO bonds. CO bond is a polar bond due to the difference between electronegativity of the two atoms. Since electronegativity of oxygen is greater than carbon, therefore there is the difference of electronegativity. But since the arrangement of the bond is linear, the net polarity is 0, and hence it is a non-polar molecule. Next point is polar dielectrics. Just opposite to the non-polar dielectrics, in polar dielectrics, the center of mass of positive charges does not coincide with the center of mass of the negative charges within the molecule. And in contrast to the non-polar dielectrics, the reason behind this is the asymmetric shape. In the absence of electric field, each molecule has intrinsic permanent dipole, but they are randomly oriented. As a result, these materials have no net dipole moment. This point says that each molecule has dipole moment within the material, but the net dipole moment of the material is zero in the absence of electric field. When some external electric field is applied, then all dipoles tend to align themselves with external electric field. But the thermal agitation tends to keep the dipole randomly oriented. Hence, the partial alignment of electric dipoles is produced in a polar dielectric medium for a specific field strength. However, the alignment of dipoles can be increased by increasing the external electric field and decreasing the temperature. So we can say, in putting the polar dielectric in an electric field, the alignment of the small dipoles occur, but due to thermal agitation, they again randomly distributed in all over the material. As we increase the external electric field, all the dipoles get aligned in the direction of electric field. So there are two factors which are responsible for this. First is the electric field which has applied on the polar dielectrics, and second is the temperature. Higher the electric field and lower the temperature promotes the electric effects within the polar dielectrics. Examples are ammonia, hydrochloric acid, water, etc. Next topic is electric polarization. The polarization occurred due to displacement of positive and negative charge in the molecules of dielectric material when it is placed in an external electric field is called electric polarization. To understand this phenomena, let us consider a dielectric placed in an external electric field E0, which is maintained between two parallel plates having opposite charges as shown in figure. Dipole moment induced in each molecule of dielectric, so there will be a net induced electric field within the dielectric due to polarization in molecules. Therefore, we can write effective electric field in a polarized dielectric is E is equal to E0 minus EI. As we can see in the figure, the induced electric field is in the opposite direction of the external electric field. So, the negative sign is there in the expression. Here we can see from the equation number 1 that electric field get reduced due to polarization occur in dielectric by placing it in external electric field. And you also know the expression E is equal to sigma by epsilon, which you have studied in previous lectures. that is electric field is equal to surface charge density divided by permittivity of the medium. So this is the induced electric field, which is equal to sigma by epsilon. And now we can define the electric polarization and can write its expression as the electric polarization is dipole moment per unit volume of a dielectric material and is denoted by capital P. Here we can write dipole moment per unit volume as P is equal to N into small p. Here N is the total number of molecules in dipole and P is the dipole moment of each molecule within the dielectric, which is equal to Q into 2A. And the unit of P is coulomb per meter square. And this is the same unit of surface charge density, sigma. Therefore, we can write electric field induced within the dielectric is equal to P by epsilon. Next topic is polarizability. If there are n number of molecules in dielectric and P is the induced dipole moment of each molecule, then it is found that this induced dipole moment is approximately proportional to the external electric field E naught. Therefore, induced dipole moment is given by P is equal to alpha epsilon naught E naught. Here alpha is the proportionality constant and is known as atomic or molecular polarizability. Its unit is meter cube, and for most of the atoms it is of the order of 10 to the power minus 29 to 10 to the power minus 30 meter cube, which is also the order of atomic volume. Moving to our next topic, which is electric susceptibility. Electric susceptibility indicates the degree of polarization of a dielectric material when it is exposed to an applied electric field. And was found that the electric polarization is directly proportional to the reduced value of electric field. So we can write P is directly proportional to E, or P is equal to epsilon chi into E, and the direction of P will be same as that of E. In the last expression, chi is the proportionality constant and is known as electric susceptibility. It describes the electrical behavior of dielectric and has different value for different dielectrics. The value of chi for vacuum is equal to 0. Here epsilon is used to keep chi dimensionless. Next topic is relation between electric susceptibility and dielectric constant. Here, by using equation number 1 and 2, we can write E is equal to E naught minus P by epsilon naught. So, by putting the value of P, we get E is equal to E naught minus epsilon chi E by epsilon. Epsilon will get cancelled out and the final expression of E naught is equal to 1 plus chi into E. Or we can write E naught by E is equal to 1 plus chi, or K is equal to 1 plus chi, where K is the dielectric constant and its value is E naught by E, which you have studied in previous lectures. The dielectric constant is a parameter characterizing the ability of some materials to polarize. And next is dielectric strength. The dielectric strength of a material is a measure of its electrical strength, and it can be defined as the maximum voltage required that a dielectric medium can withstand without breaking down of its insulating property. It can also be described as the highest voltage needed to induce a dielectric breakdown. Dielectric strength is expressed in volts per unit thickness, that is volt per meter. Let us know about the differences between dielectrics and insulators. Here is a comparative chart of difference between the dielectrics and insulators. So, first is the dielectrics are the material in which an electric field can develop with the minimum loss of energy, but insulators are the substances which have low conductivity and create obstruction in the flow of current. Dielectric can be polarized in an electric field, but insulator cannot. Atoms in dielectrics are weakly bonded within the molecule as compared to the insulator, but there are very strong covalent bond among the atoms within the molecule of insulators. There is very high value of dielectric constant for dielectrics, and insulators has low dielectric constant. Dielectrics store the charges, but insulators obstruct the charges. For example of dielectrics: dry air, vacuum, distilled water, etc. And the examples of insulators are cotton, plastic, mica, etc. Some applications of dielectrics are used in capacitor, in power cable, etc. And applications of insulators are used in conducting wires and in high voltage system for insulating, etc. Thank you.